All right. Okay, yeah. Now it should be on recording. Okay, so now, first of all, we are going to be going into introduction to data visualization. Whenever when we are trying to visualize data, at first we will always see a lot of data in here. So let me show you an example, right? Okay, so now take a look at this sample of data set, right? Okay, now we have student ID on the left hand side, name, we have gender, we have intake year, campus ID, course ID, attendance, and CGPA. So if you're a student in TAUMT, I'm pretty sure you are pretty familiar with this. What data set is this? So this is just this is just the records of all students in TAUMT, and then we have the campus, we have the course they take, and the attendance rate and CGPA. So now imagine you are the person who are trying to explain this whole record here. You are trying to explain this to maybe your president or somebody who's trying to make decision, okay? And you want to summarize these details, okay? So you need to know what kind of information you want to summarize and then make it into something that they can understand. So now let us just pick 3 random information here, okay? Now, the first one will be gender. We want to summarize gender. And then secondly, we want to summarize the attendance rate. Okay, take note, the minimum attendance rate has to be 80%. And then lastly, we need to summarize the CGPA. Now, usually people who look at this data set or when they are trying to make decision, they don't have that much time. Usually around 2 minutes of observation and they are already done. So our job is to make sure that they can capture the information within 2 minutes. So now we have 2 options right here, okay? Now, for the first option, we are going to write a report of the information that we have just now, okay? So as you can see, we have the gender right here, we have the CGPA, we have the attendance rate right here, and it's written in 3 paragraphs. This is the first option, okay? And then the second option right here, we can see a lot of graphics. We can see a lot of images here, different charts with different titles, right? And different numbers here. And we have some kind of keywords in here. So now I want all of you here to give me your preference, okay? Your preference based on which kind of option you would choose when you want to explain this data set right here to to the client or the person in charge trying to understand students. If you think option 1 is the better option, raise your hand in here, or you can just write 1 or 2. If you think option 1 is the better option, raise out your hand. Okay. If you think option 2 is the better option, raise out your hand, or you can just type 2 in the chat. You can type 2 in the chat. All right. Okay, I see some feedbacks on option 2. Yeah. So if you're trying to present this information to your client, usually we want to make them easier to understand. And for all of us, I believe, unless you're a special one, okay, unless you're the special one, most of the people will prefer image, something like this with simple sentence instead of this long sentence with like around 60 to 70 words in one paragraph. No one can read this within 10 seconds and then straight away understand the meaning. But if we put image in here, if we put this image, some keywords, some numbers in here, most of the people can get the information a lot faster compared to option 1. And this is why we usually will go with option 2. So this is what we call data visualization. We convert them into this kind of image so that people can understand faster and easier, okay? Now let's go into the main meat in this event. It's about data visualization. So what is data visualization? Data visualization is a process, okay? It's a process of us using graphics or visual elements. So in which case just now we are using the images, right? And then we want to present the data in a format. We want to present data in a format where trends, outliers, and patterns in the data are easy to understand, right? So just now, if we pick option 2, we can straight away see there are 3 images. The first one is gender. The second one is attendance. And the third one is CGPA indicator. We try to make them, we try to make smaller parts in here, separate them, and then we make it into visual elements, images that are easier to understand. And then from these colors, from these numbers, we can then see the pattern inside the data or the information. This is what we are trying to do. And what does this help us? It helps us in making quick, informed decision. Okay, we are trying to understand the situation as fast as possible, and then we can decide what we should do next. This is how important data visualization is. Okay, now I've break it down into 4 purposes for data visualization. So let's look at the first one first. Okay, first one is analytics. The meaning of analytics in here is that we are trying to show this kind of data, and we can then see or analyze what is the difference between like maybe 2 different categories in here. Now, as you can see here, we have 1 long orange bar and 1 short blue bar. So based on our analysis, we can say that, oh, the orange bar has a higher value compared to the blue bar. And if we do calculations on it, we can then see how big is the difference, And this is how we perform the analytics. And by combining all these together, we can then get our final decision, final recommendation. This is how analytics works. And because of data visualization, we can perform analytics faster. Okay. So next one is exploration or connection. Okay. Exploration or trying to find the connection in data is a bit harder because we need to do a lot of calculations. Only then we can understand. So how data visualization makes it faster? Okay. Now, when we go back here, we have female having more students compared to male. And then we can have attendance here. Let's see. We have IT01, okay? IT01. And then we have red bar here. And then we have green bar here. And then if you look at this CGPA indicator here, this graph right here, and when you look at this class here, you can see that the attendance rate is also grouping IT01 and BI02 separately. And in the CGPA indicator, we are also seeing IT01 and BI02. They are all separated. So if we are trying to do connection, we can look at the attendance rate right here. We can look at the attendance rate, and then we look at the CGPA. And from here, we can try to relate or try to understand what is the relationship between attendance and indicator. Maybe if attendance is higher, CGPA will be better. Or maybe attendance is higher, CGPA will be lower. We need to use data visualization. Only then we can kind of see, oh, there is a connection between these 2 indicators. This is how we can do connection, or how we can look for connections or explorations by performing data visualization. Okay, so next one is storytelling. Like I said just now, if we are trying to convey information, to the client, we want them to understand the information better, which means we need to make sure that we can explain the whole story with important details inside here only. We don't want to write long paragraphs and then they ended up not understanding anything. We want to make it into images so that, we can tell them the story of gender, we can tell them the story of attendance, we can tell them the story of CGPA indicator, and then we can tell them the priority. This is how storytelling works. We have the introduction, we have the content, the body, and then we have the closure, the conclusion. This is similar to how our data visualization helps in storytelling. And lastly, and the most important one, is definitely decision. Okay, we are always looking at data, we are always looking at information to understand the situation, and then we can make decision, right? If I just look at this whole data set, I just look at this data itself, I can't really see the difference or the important keywords in here. Unless I go and purposely make graphics, make images with some calculations so that I can understand better about the data. Only then we have the priority so that we can only understand what we should do or next what we should do first, right? This is why decision is the most important one or the main purpose for us to perform data visualization. Okay, so who needs data visualization? Like, oh, okay, so I know data visualization is very important. So who needs it? Right? The ones who need it are organizations. Okay, organizations, because they are trying to do their business. If you want to sell something, you must make sure you understand what does the customer want. So organizations need to perform data visualizations so that they can see the connection and then they can then make decisions. And next one is definitely decision maker. This decision maker is not just organizations. This decision maker includes every one of us here in this call, in this event, and anyone else outside this event. Everyone who needs to make decision will need to be able to understand the information in their head. Only then they can make decisions, and data visualization helps them to do that quicker. Okay. Next one is business analyst and data analyst. Okay, this is pretty much a very obvious one because business analysts and data analysts, their job is to understand the data itself and tell the client what is the important keyword, important take right there, which is why business and data analysts will definitely need to know how to perform data visualization so that they can help people to make informed decision. Okay, now we already know who needs data visualization. What are the tools we can use right here? So for example, we can use Jupyter Notebook. Okay, Jupyter Notebook is one of those tools that can help us perform data visualization. They can draw out images using Python language. And then the other one would be Google Colab. This is also similar to Jupyter, but this Google Colab is made by Google itself. They also allow us to use Python and generate the image so that we can understand the connection or the important information. Next one would be SAS. Okay, SAS is more popular in the data science region where this is mainly for those data analysts when they can use SAS to create a lot more types of images instead of the simple ones in Python. So SAS is also one of the more popular tools in data visualization for those in data science industry. Okay, the next one is Tableau. Tableau is a pretty popular one when for those people who are just new into business. Usually, if you are new into business, Tableau is a better option for most of the people because Tableau doesn't need anyone to understand coding. The only thing you need to do is to just get the information, put it into the system, and this tool will help you generate the images by itself. And you can pick based on what you want. So Tableau is a more beginner-friendly kind of tool. And the last one is the most obvious one and the ones that we have the chance to keep on touch with. It is Microsoft Excel. So maybe not all of you are actually familiar with this, but in Excel, you can actually create graph. You can just key in the data into it, and then you just highlight the data and then convert it into a bar chart, line chart, or any other graphs that you want in Excel. So if you have no idea how to install Tableau, you have no idea how to use Python or SAS, Excel is your best beginner-friendly option. You can open it right away and just key in your data, and then just click on the data visualization, and you can visualize your data straight away. Okay. So now next one, we are going into the basic data visualization techniques. Okay. So for this event, we are going to be learning 3 data visualization techniques. Most of you have heard of it before, but we will try to recap a bit before we get into the Python part. Okay. So the first one will be pie chart. Okay. Pie chart. As you can see here, we have this example here. We have the student count and all these portions right here. So the way it looks in pie chart is that you have a circle with a lot of labelings in here, like year 1, year 2, year 3, and graduate. And then usually we represent this data in fractions or proportions. means like this one is 30.4%. This one is 21.4%, and this one 25 and 33.2. And the main usage is for us to make quick presentation of those that are in similar categories. Because for this one, we are all trying to we are trying to present the number of students for different categories, for graduates, year 3, and other years. And then we want to present the student count. So pie chart is really good in doing this, and it's a lot more direct and allows quick understanding for us to know what is the information about. I can just tell you, year 1 has more students compared to others. This is how direct pie chart is in this case. And although we can do this kind of data visualization, there is something that we need to take note, is that it usually overwhelms easily, okay, with more categories. So let's say instead of year 1, 2, 3, and graduate, let's say we have year 1 until year 200. Year 1 until 200, and then each of that takes like 0.5%. You will see a lot of tiny sections in here. And for most of the people, you will feel intimidated by it because there are too many categories to read, too many categories to look at. So at that point, it's not the best way to convey this kind of information already. So we need to take note on that. And the other downside for pie chart is that it only compares one group of similar categories. Yeah, it only compares one group of similar categories. So we can only, let's say we are trying to compare student count for this whole pie chart itself. Okay, for this whole pie chart itself, we can only compare the student count. We cannot suddenly include CGPA or attendance into this pie chart. It doesn't work that way for this data visualization technique. So these are the ones that you need to take note of. Okay, so far so good. Is everyone fine with it? Or do you guys want me to go slower a bit? Yeah, okay. So I'll just continue with this similar speed. Okay. All right. Next one. The next one will be bar graph or bar chart. Okay. This data visualization technique is pretty obvious. We are going to be using bars, and in this case, we are using a lot of rectangles right here. Rectangles right here, and we align them by category. So we have year 1, year 2, year 3, and graduate, similar to the previous one. And usually we represent them in actual values. So if year 1 has 100 students, we will draw the rectangle right until 100. And it goes the same for other categories. Okay. So the main usage here is that if we have too many data, like for just now pie chart, it easily overwhelms people when we have too many categories, right? So if we want to represent as something that is larger, or something that has like really, really large value, let's say 1 million, 2 million, 3 million, something like that, bar graph would be the better option. Bar graph would be the better option for this kind of situation. And one good thing is that they can actually show us how is the distribution. Like if we look at this one, we have FOCS as the green color. Non-FOCS is the orange color. So if you just look at the green buff itself, we can see that the number of students are getting less and less for FOCS students. But if we look at non-FOCS students, which is the orange bar, okay, we look at the orange bar now. If we look at the orange bar, we have year 1, year 3, similarly, similar in the number. And then we have year 2, like a lot less. And suddenly we have a lot of graduate students in the same year for non-FOCS. So if we look at it this way, we can start to see, for FOCS, the number of students who graduate are always less than year 3, year 2, year 1 students. As for the non-FOCS, the orange bar, we can see that there are a lot of graduate students in this year, 2017. So this is how we can see the distribution. This is one good thing about bar graph. Of course, we do want to take note on certain downsides that bar graph has, is that sometimes patterns or trends, we can't really notice them. The reason is like this. Let's say if we have let's say we have like 100 students this year, and we have 101 students next year. And then And then the other year, we had 98 students. And then after that, we have 120 students. So if we just listen to the number itself, we see 101, 100, 101, 98, and then 120. If we visualize by ourselves, we can see that, oh, it's going down, it's getting less, and then it goes up, and then it goes up again, or it gets lesser again. So we can visualize it. But bar graph, they can't really show the trends sometimes, because if the number is too small, so small that the bar graph doesn't really change. In this case, like, oh, we have 75 here, we have 100 here. If the bar graph doesn't change that much, and other bar graphs are so close to the previous graph, then we can't really see the pattern. We don't know what actually happened in this year or for any situations similar. And the next one will be the accuracy really depends on how we draw the bar graph itself. So in this case, right, I've drawn the bar graph from 0 to 100 by 25 each. So if we were to draw this section, instead of 25, 50, 75, 100, I draw 0, 50, 100, 150, 200. Since the numbers are a lot closer to each other, if the scaling becomes too large, the bars here, they tend to get a lot closer to each other, which is similar to what I said just now. Because the way we draw the bar are a lot closer to each other now, we can't really see the difference, and we don't actually know if the number of students are actually this close to each other, unless we look at the scaling or we change the scaling. Because if we are to say by number, 1 million and 2 million are big difference, right? 1 million and 2 million are big difference. But if we were to draw it on bar graph, and then we use 5 million as the scaling, then 1 million and 2 million looks so close when we draw it in the bar graph. And this is not a good thing, because we can't show the pattern, and other people might interpret it wrongly. So this is one downside of bar graph that we need to take note. Okay, so the next one will be line graph. Okay, line graph, we draw lines. The main appearance is that we have lines drawn through a timeline. Take note here is that we are drawing it on a timeline. Okay, so if we look at the graph right here, the graph started from 2017, year 2017, continue from 2017, 18, 19, 20 until 23. So for line graph, usually we draw this, or we visualize this by showing it in a timeline. If we want to represent something that happened from the past years until the present year, from last time to now, we use line graph to show what happened during that time and how did it change from that time until now. So and usually we represent them with actual values. This is similar to bar graph. We have 100, 200, 300, 400 right here. The main usage is very obvious because we have timelines right here. The main purpose for us is that we want to draw we want to show the actual change. We want to show them, oh, this is the pattern that we can see from 2017 to 2023. This is what happened. Oh, it goes up and then it goes down throughout these 7 to 8 years. Okay. The next one will be, we use it to compare multiple categories in the same timeline. Okay. Take note, in the same timeline. So if we have 2017 and 2023, look at here, you can see here that I've already drawn it into 3 different lines: orange color, blue color, and red color, which are these groups. So what we can do is that we can compare the pattern for this orange bar with this blue bar and this red bar together, and then we can tell them, oh, we can see different patterns in these categories, and maybe there are some hidden connections that we might not see. And this is how it works in line graph. Okay, there is a few things to take note as well in line graph, is that it's similar to pie chart. It overwhelms easily with more changes. Okay, it overwhelms easily. If you have 200 lines here, I bet none of us can actually understand or can actually see like each line individually. If you have 7 lines and 7 lines use different colors. And if let's say we have this orange bar, we have this orange line here, it goes down, goes up, goes down, goes up, goes down, goes up. It looks a lot more obvious because it takes a lot more space in the graph. But if we were to keep the red graph, something like this here, because the orange bar went down, went up, went down, went up, went down, it covers, or it might affect us in trying to understand the pattern for red line only, because the orange line had already covered too much area, and they might confuse us. They might confuse our brain when we are trying to read it. And it's also less effective with when there are like really small changes when we can't see. It's similar to bar graph about the scaling issue. So let's say if I have 100 students for the first, let's say we have 100 students in the first year for this red line, and then we have 101, 102, 103, 104, and then suddenly 99, 98, and then 100. Because the scaling is too large, we also can't see the difference in that. And this happens when we have like really small changes. It becomes a lot less effective. All right. Okay. So these are the 3 data visualization techniques. So the next one, we will go into our hands-on section, and I'll be demonstrating into you how we can visualize these data in Google Colab using Python. Okay. So now I've already opened this link right here. This is called colab.google. Okay, if you have the time, you can go and check it out. It's a pretty good product that Google has made. We can press here, new notebook. All right, okay, we have got into the new notebook right here. So this is what Google Colab looks like if you have never used it before. Okay, and then we have this section here. This is where we put our Python codings in here. It's okay. If you have never learned coding before, this will have not that much complicated codings. Later, when you go through it, you will understand. Okay, it's not that hard this time. You don't need a lot of knowledge for Python coding to do this data visualization. Okay, I'll guide you through one by one. So first thing first, the few things you need to know is that if you want to add Python codings, we use this one. Okay, and if you want to delete the coding, we can use this button here. Then we can delete it. All right, and then if you want to run the coding, you can see this play button right here on the left hand side here. You can press this to run the coding itself. Okay, so now let us import some things in Python. This one you will need a bit of knowledge, but it's okay. For now, you can just look at it and see how I do this. Okay, so if you want to visualize data, we need to import 3 very important functions that Python has. So the first one will be import pandas, and the second one will be NumPy. This one, the next one will be matplotlib. Okay, these are the 3 important functions that Python has that we need. Okay, if you want to know what are the general functions that they use, so for Panda, okay, you can take note on this. For Panda, we are trying to use this to extract information from CSV file or Excel file. Okay, this is the main purpose that we will be using this time. And then next one, for NumPy, we are going to create a list of data or information using NumPy. And lastly, matplotlib for this one, we are going to use it for data visualization. So these are the general functions for these modules. You can take note of this, so next time when you try to do, you won't get so confused when you try to replicate what I did. Okay, and the next one for this case, okay, we need to import the drive in here because I can show you here. I already imported a student data CSV file, and this is how it looks like inside here, similar to what I've shown you just now. We are going to be using this data set for our data visualization. Okay, so I can have, we need to use from Google Colab import.drive. Okay, This is to connect Google Colab with Drive. This is the main purpose for it, okay? So we can then just run this, pressing the play button right here. And then down here, you can see it is trying to connect with the Python. Okay, done. Next one, okay, we can add another code cell right here. So now I'll try to import my CSV right here. Okay, I want to import this data set. And this is when we will be using our pandas. Okay, now if we want to import this data, we can use pd.read CSV. Okay, this is to let the Python read, this is to let the system to read the CSV file itself. And then we just need to paste the path. Okay, and this is the path to get my CSV file. Okay, and then I can run this. I need to link here. Yep. So in here, you see this is a drive. And if I were to get my CSV file, yep, that. So as you can see, let me show you right here. This is the data file. This is a CSV file. So you can just click and then just copy path and paste it in. Okay. Now, next one. Now already imported the CSV file. Okay. We want to look at the CSV file for a bit. So just to make sure, okay, just to make sure that the one that we imported is this one, because we don't know unless we check it out by ourselves. Okay. So what we need to do, add another code cell here, and then we use data.head. Okay. Head means look at the first 5 rows of the data. This is what head does. Okay. So if you run this again, now we can see this is the data set that we have imported. We have the student ID, name, gender, intake year, until CGPA. So we have already double checked, and this is the correct data set. Okay. Now, next one, we are going to introduce the pie chart. Okay. We are going into the pie chart section right now. So let me go through with you what we should do in our pie chart section. Okay. So this is this is for pie chart. Okay, this is generally how the coding works. Okay, it is not that complicated. Okay, please be rest assured about that. Okay, it won't be that hard. You just need to know a few lines of coding. So the way we do coding for pie chart is that we use these keywords only, plt.py, and then we import the values of our data. Okay, we import the values. Let's say for this case, if you want to import the gender, so we include the genders data set. So we will go through with it later. And then we just need to show them. That's all. This is how the coding works for pie chart. There are some attributes that we will use to make the image, to make the pie chart look better. And these are the few examples for it. So we have labels, start and go, expert, shadow, and color. Okay. Now it's okay. We will go through step by step. Okay. Now let us open another code cell. So this is the pie chart section. All right. Okay. Now, first of all, we need to look, if we want to get the pie chart for gender, we need to first know what are the how many female students and how many male students in UMT. So how we can do that? The way we can do that is that we can first write out this one. We can call the data set that we got just now. Okay, data, right? This is the Excel, this is a CSV file that we got just now. And now we want to group all of them together. We want to group all of them together so that we can only see the gender. We only want to know the number of students in different gender. So we need to group them together first. Okay. And then we want to group the gender itself. Okay. See this? We have all this information, but we only want to look at the number of students by gender. So we group all of them together first. Okay. After we group all of them together, we need to write the size. Size in here tells us the number of values for each type of gender. Okay. So if we run this, if you look at here, we have F 180, M 205. So what happens is that we've grouped 385 students into two different genders, male and female, M and F. And after that, because we want to know what the number of students in each gender, we use size. This is what it tells us. So now we have the number of students, in different gender for these two categories. Okay. So now, what we want to do now is that we want to put in the values into the pie chart here so that we can visualize it out. Okay. So what we want to do now is to create something. Okay. We need to create something called np.array. np.array, just treat this as like your container. Okay. Array is like your container. And then in this container, you have different sections, section A, B, C, D, E until the last section. And what we are trying to do is to give each section a number. This is what we are trying to do. We want to store this number in this container so that when we want to use it, we can use it straight away. Okay, this is how it works in array. So now, because we know we have 180 females and we have 205 males, so we can put 180 and 205 for this array so that now in the system's mind, they know that for the female section, we have 180 people. For the male section, we have 205 people. Okay, and then we need to assign them a name because the system can only remember them if we give them a name. So what do we give them? Because we know these two figures, this tells us the number of female and male students. So we can write gender count. Okay, gender count. So this name itself tells us that, oh, this is a container that tells us the number of students for each gender. This is what the name does. Okay, now we can then continue. Okay, now we want to plot the pie chart. We already have the values in here. Okay, we already have the values in here. So what we need to do now is just like what I showed you just now, plt.pie and plt.show. Okay, so now plt.pie, we want to put in the values of the gender. So we put the gender count in here. Okay, and then we just need to show them. Yes. Okay, now let us run this and see what happened. Okay, as you can see, we can now see a pie chart right here. So one of them must be the female and one of them must be the male. Okay, so now we are done with this. Okay, now Jet, I want to know which part is female and which part is male. So how can we do that? Okay, the way we can do this is simple as well. We just need to give them labels. The way we give them labels is also similar to this array thing. We want to give them a container so that they know which one is the female, which one is the male. So what we need to do, we write np.array, and then we put in the labels that we want to give. One of them is female, right? So we want to give them female, and the other one is male. So we want to put male in here. And then we just need to give them a name. Gender label. This is the label for the pie charts that we are going to be using. So we just need to write something like this. Okay. Then what next? We just need to put the attributes behind the values in here. As you can see, I have only included 2 lines of coding right here. So if we want to include other attributes, right? If we want to include these attributes here, just put it right behind the values in here. Put it right behind this section. So this is what I'm doing right now. I want to give them labels. Okay, I want to give them labels. So I just write labels. And then what labels are we using? We are using this one, the one that we gave them. So we just put gender label. And then we just run one more time. Here, now we have female and male. So now we know female is this section, the blue section, the male is the orange section, right? Okay, now we already have the labels. Jet, I don't want to see the pie chart like this. I want them to start from the top. I want the section to start at the top. So I don't want this line start right here. Okay, now it starts at here. I want it to start at here. Okay, I want it to start at here. So how can we do that? So to do that, we can use start angle. Okay, start angle means where does the line start drawing the pie chart. So if, let's say, for this one, if by default, we have the line starting here, and then everything is drawn based on this line. So if I want to make the pie chart start here, I need to give it 90-degree rotation. If I want it to start here from the left-hand side, I need to give it 180-degree rotation. And as for the bottom is 270%. All right. If I want to start at the top, I need to give them 90-degree. So what we are going to do is also simple. We just need to put the attributes behind. Start angle, okay? Start angle. And then we just need to tell them which angle to start at. So just now, I already showed you, this is the 0 degree. This is the 0 degree. If I want to start at the top, we use 90-degree. So we just put 90. That's all. Run again. Okay, let's run again. See, now it starts from this section right here. It starts at the top now. It doesn't start from the right-hand side, left-hand side, or down, or the bottom. It starts at the top. This is what start angle does. Okay, so now we are going to keep on improving our pie charts. Okay, this will be how we can, for the following sections will be how we can include attributes to make it look better. Okay, so now let us emphasize for better label, for more sections. Okay, now I want to make the chart look something like this. I want this pie chart. Let's say for female section, I want it to be separated from the center. The center is right here, and then I want the female to be away from the center, so that when people look at the pie chart now, they will look at the female first rather than the male first. Okay, so the way we can do this is that we give them another attribute. Okay, we call them explode. Okay, explode. Okay, explode is the way we make them separated from the center. Okay, so what should we do? We need to give them the values for how much they should be separated from the center. So similar to these two right here, we need to create another array. Okay, we need to create another container to store this value. So for explode, we put values in here. So let us just put a random number called 0.1 and 0. So what happens is that the first one will always correspond to the female category. The second one, which is 0, will always correspond to the male category. So if we just look at this meaning by itself, is that the female will be away from the center. The female section will be away from the center. Okay, and then similarly, we need to give them a name, gender, explode. Okay, and then we just need to copy this name, put it in here. Oh, put it in here. Yep. So now, supposedly, okay, now let's take note of this. Supposedly, the female pie section will be away from the male section. Okay, this is one thing we should take note, right? Okay, take note of this. Okay, let's run. Now, the female section is now separated from the center right here. So what happens if we put 0.1 on the male side? Okay, let's redo. Now we can see the center is right here, this part, this section, and the female is away from the center by 0.1. The male section is also away from the center by 0.1. The center should be right here. So this is what it does. So let's just say we want to emphasize on the female section. Then we just put 0.1 for the female, and voila, we are done. Okay. Now, Jeb, I don't think we can understand these colors that well, because commonly males are usually represented by blue color, and the woman, the female, are usually represented by pink color or red color. So can we change the color for this one? Yep, we can change the color. Similarly, give them a container name. and then we need to give them the colors that we want them to put. Okay, so for the female ones, let's give them hot pink. Okay, hot pink color or anything. It depends on what we have in the system. And then for the male one, I want a color called blue. Okay, and this is the gender color. And then we just need to put the attributes right behind. Simple, direct. Just put the colors at behind. Okay, this is the attribute name, and then we just need to put gender color. Now when we run again, see, now we have the female section in hot pink and the male section in blue color. Okay, maybe some of you might think that, oh, this blue color is a bit too dark or too bright. Can we change it to something that's lighter? Yes. If you want to change it to other colors that are not in the Python, we can use the hex code. Okay. For the hex code, this is one, the HTML color hex code. We can also use this hex code and then we put it in. Okay. So let's say I already picked one color that is slightly lighter. Okay, slightly lighter. You can H0096C7. So just have a look on what the color looks like. So this is what will the color, this is the color itself. Okay, so if you run the coding, the male section should use this color. Okay, so now let's run this again. Okay, now the blue color looks lighter a bit. It's not that bright, it's not that dark. So it looks a bit more comfort in the eyes. So this is how we do the color changing for this one. Okay, now we have included the color. Okay, now we want to show the percentage, right? Because in this part, we always should tell them, there are 46.75% of them are female or male or something. So we want to show them the numbers, only then they can understand more. Because if we just look at this, we know the male students are more than female, but we don't know by how much. Okay, we don't know by how much. So what we want to do is that we use this attribute called auto PCT. Auto PCT means all percentage. Okay, and then what kind of percentage format do we want? So this one you might need a bit of knowledge, but let's just follow for this for now. We put %.2f, %. This is the format that we will be using. So what does this mean? Okay, let us run once and you will understand straight away. So this format, %.2f, %, let us display the pie chart in these two figures. We have two decimal places with % sign. This is what the format tells us or tells the system about. Okay, we just need to do something like this and it's already done. Okay, now let's say I want to put shadows in here because it looks too simple. Maybe some of them I feel like this is too simple, so we want to add a bit of color or shade in there. So we can use shadow, and then we put true. We want the pie chart to have shadow in there. So when it runs, you can see a hint of black, a gray color, gray shade below this pie chart. This is what shadow does. Okay, and then next one, we want to give them labels because we already included the females and male here. So what if we don't want the labels to be all around the place? We want them to be at a fixed place, like something like this. We want the gender to be right here. We want them to be at this spot. We can do that. Okay, we can do that by giving them the coding called legend. Okay, plt.legend. Okay, plt.legend, and then what we want to give them? We want to give them the labels. So we want to let the system create the legend or the labelings. Okay, create the labelings based on this one right here. So we just need to tell them, and we just need to give them the values and then tell them these labels represent the gender. This is the title. So when we run this again, now we can see the gender for female and male for different colors. This is what we do if we want to make the labels fixed at one spot. So now, Jeff, since we already have this legend, technically we don't need these labels already, right? Yes, if you can pick either one, you can pick either legend or you can use the labels right here. Since we want them to be at the same place, so we just remove labels and then we just use the legend. So now what you see is something like this. We have gender, female, and male. Okay. Now next one, we want to include the title in there because I want to know what this pie chart is about. We want to know what this pie chart is about. So what we need to do is to include plt.title. Plt.title means we give this pie chart a title. So what this pie chart is about? So we can say this is a pie chart of UNT students by gender. So we now tell them that this pie chart is about UNT students grouped by gender. When we run this again, here, pie chart of UNT students by gender, and done. Now we can see that this label right here, it's slightly overlapped with the pie chart. So we want to make this pie chart a bit bigger. This whole figure, this figure right here, a bit bigger so that it does not overlap with each other. So what we can do is that we include one last line of coding called plt.figure. Okay, this is to help us change and do the settings on how large will the pie chart be. So we can put fixed size, and then we want them to be slightly larger. So we can give them 5.5 inch and 5.5 cm or inch and 5.5 cm or inch for the length and the width, the height. So when we run this again, now it is slightly larger, and done. This is how we can do Python coding and get the pie chart that we want. It doesn't really take a lot of time, but it requires your understanding on what elements we can use and how should we represent the data. So it won't be that hard. Okay, so far so good. Is everyone okay? If everyone's okay, I'll continue with the next one, which will be the bar chart. Yeah. Right. Okay. So far so good. Yeah. Okay. I'll continue with the bar chart section. Bar chart section, it won't be that difficult as well because it's sort of similar with pie charts and line graph as well. Okay. So now next one, let us continue. Now this is the bar graph section. This one, similar, we have the basic codings of plt.bar. Okay, plt.bar is similar. It's similar to pie chart. For pie chart, we use pi. So for bar chart, we use bar instead. That is all. And then we have some different attributes in here, but they are pretty much similar. So you won't have that much, you will see a lot of similar things in here, right? We have bar chart and then PLT show. These are the common attributes: color, width, height, bottom, and this one. This one, I'll introduce it later on. Okay, so it's okay. So we can ignore this one for now. And then for the basic coding, if we have two bar charts here, okay, as you can see, if we have two bar charts, we want to create one line of coding for the first bar chart and the second one for the second bar chart. And then we have X, and then what we want to put in is that we want to put in the X value, which in this case is the year right here. And then the second one will be the Y value, right here, the number of students. And then we include the other attributes and so on. Okay, so now I'll continue from here. Okay, let us create a new line of coding. So this one, we are going to introduce the bar graph section. Okay, so just now we included the intake year. So this time we want to get the intake year instead of the number of students based on gender. We are looking at the intake year itself. So let us do the same thing on what we did just now. As you can see, we did data.group by. We want to group them by gender just now. So now this time we want to group them by intake year. And then we want to get the number of students after grouping it in them. So if we run this again, similar to the gender, for the gender we have F and M, right? For this one we have 2021, 22, 23, and 24. It is something similar, okay? Now, next one, if we want to continue from here, we just need to make all the containers in here. It is similar to what we did in pie chart. It's just different name, different values, okay? So let us create another code cell. We can let's just copy one or two so that we can refer it back straight away. So what we want to do now is that we want to group the number of students based on intake year instead of gender. So we can follow similarly with the one we did for gender. np.array, we create a container for them. We put in the values 22, 120, 84, 159, and then we give them the name. So we can put intake year count. This is the name that we gave them. Okay, and after this, we also need to include the number, the intake years in here, because if we can recall, we need the X value in here. For this one, 22, 120, 84, and 159, this is the Y value. The one on the left-hand side right here. The one on the left-hand side right here. These are the values for number of students. So we need to make another one for the intake year itself. So we need to create another one called intake year. And then we need to set 22, we need to give them the figures 2021, 22, 23, and 24. This is what we are supposed to do, okay? And now, we already have the intake year ones. We just need to put them into the bar chart, the bar coding, the coding for the bar section. So what we did was we include X value and Y values, okay? We just need to put them accordingly. So we want the X value to be the intake year. Copy and paste, okay? Second one, we want them to display the number of students for each intake year. So we put the intake year count, and then we just need to show them, okay? Done. Okay, nothing really complicated. A bit of understanding on what we can do, and we can make a bar chart straight away. Okay, now from this bar chart right here, if you look at the X value, they are all in decimal places. This is weird because by our logic, supposedly all years should be in whole number, right? We only have year 2020, 21, 22, 23, 24, 25. We don't have year 2021.2. We don't have this kind of year. All years are in whole number. So we want to make them display in proper number, right? The way we can do that is that we introduce another line of coding called plt.xticks. Okay, ticks means the labeling. What labels do we want to include? The labels that we can only include. Okay, so the ones that we need to include are 2021, 2022, 2023, 2024. Now, as you can see, the labels are now in whole number instead. So why is it this way? Because in this line, the system thinks that this is a number. If it's a number, it can be a decimal number, which is why the system printed out 2021.0. But if we put X ticks here, it lets the system know that we only want these 4 values in the in the horizontal section. We only want these 4 figures in here, which is how the system can change it and only display whole number right here. Okay, if you want to display it in horizontal bar, we can put bar H. Okay, we can put H behind the bar and it will display horizontally. Except this one, because this one we need to change to Y ticks. See, we can make it into horizontal version of bar chart. So you can do it in any manners that you want. It depends on your creativity and your understanding. Okay, now we can straight away go into the attributes. These are all pretty much similar. Okay, for the bar section, we can include the color. The color, let us do something. Let's include orange. Okay, we can give them orange for the color. And now the bar chart will be in orange color. And then now I want to make the bars less thick. I want them to be so big. We can include the width section, and then by default it's 1.0. So if we want to make it smaller, let's just say 0.3. We can make the bar smaller by this. Now we can see the bar chart is using smaller rectangles instead. Okay, and then if we want to include title right here, okay, if you want to include the title right here, you can just include it in straight away, just like what we did just now, plt.title. So we quickly just copy this one, put it down here, and then we put bar graph of INT students by intake year. Run. Now we have this bar graph of INT students by intake year. Okay, so now I want to let them know that this horizontal section represents the intake year. And I want them to understand that the left-hand side here, this one here, represents the number of students. So what we can do is that we give them a label. We give them a label for this horizontal and vertical section. We just need to write in plt.x labels. Okay, plt.x label. And we tell them this is the intake year. And then we put plt.y label. Okay, and then this one will be the number of students. Done. We have the intake year and number of students right here. So now when they look at this bar graph, they know this is for the intake. This section is the intake year, and this section right here is the number of students. Okay. Now we will be entering a short break for a while. Now it's 9:12. Okay. So we will continue at 9:22. Okay, we will continue back on 9:22, and I'll continue on guiding you how we can draw the bar graph and the line chart afterwards. Okay, so now let's take a short break. I'll see you guys in 10 minutes. away from these integers too far, we now only move the female bars. For this one, we put minus 0.15. Minus 0.15 means that at this position, we move the bar chart to the left-hand side by 0.15. So when we run this again, now the bar chart moves to the left-hand side, okay? Now we have moved them to the left-hand side. We just need to add on some extra attributes or information, okay? Now we just need to include the legend, okay? We need to include the legend because without the legend, we don't know what pink bar means, what blue bar means. So what we need to do is plt.legend, and then we included this one. We included this gender label. So what we need to do is just to copy it down here. We want to make sure we know that this is the gender label. We tell the system to put the labels in here and then give them the title called gender. This is similar to pie chart. It's literally the same. Now we have a complete bar chart for this one. For this particular section, we now separated them by female and male students. Yep, now we are done already. Okay, what if I want to stack them on each other? I want to stack them up, right? This one here. If you want to do this one, we need to put addition. We need to change a bit on the attributes that we wrote. Okay, so instead of writing minus 0.15 and plus 0.15, okay, instead we put another line called bottom. We put another attribute called bottom. What it means is that this bar chart will be on top of another bar chart that we wrote. So now for this one, we put female count because we want the male count. We want this blue bar to be on top of the pink bar. So if we run this, now it'll be on the pink bar. This is how we do the stack bar chart. Okay. Now this is the last part of the bar graph. This is generally how we perform bar graph for two different values. Okay. So next one will be the line graph. Line graph is pretty simple. There are not that many attributes in here. As you can see, we only have line style, line width, and color. There's nothing much to change. Okay. So what we need to do is to just use back the same coding. To be fair, it's not that complicated anymore because now you already know how to use pie chart and bar chart. We can just straight away just use back the same one. Okay, let me get back the intake year section. We want the intake year. We can technically just do the same thing. Do the same thing right here. Okay. And then instead of plt.bar, we change it to plt.plot. Plt.plot. Put plt.plot. And then we remove the width here for now. Hopping, run. Done. We already plot another line chart in here. It's not really that complicated anymore. Okay. So if you want to configure them, we put line style and line width. So for line style, there are a few options right here. If you want to put line style, we can put dotted or dashed. Okay. If we put dotted, it will be in dotted lines. As you can see right here. If we put dash, it will be in dash lines. Yep, it will be in dash lines. Okay. And then if we want to make the line sticker, because maybe sometimes you can see them, then we give them a line width of around maybe 1.5. Now it will be slightly thicker. Okay, it will be slightly thicker. And then we also want them to be in proper labels. Include the X ticks right here. X ticks. Show them. Yep. Now we have 2021, 22, 23, and 24. Yep, it is just that simple. Okay, now we want to include the male version. Okay, we want to include the male version. Simple enough. We can just copy paste, plot, change it to male count. We don't need this one. And then we have this line start and line width. And then we just run it. Now we have both lines together already. So what's left? It's the title, the legends, and the labels. So it's pretty much the same with the bar chart. As long as you start to understand how we perform the data visualize techniques on other ones, you can technically just put them into any similar charts. At least for these three, you can just technically just copy and paste. Right? Okay. prt.title, prt.xlabel. Okay, we give them the intake year, we give them the y label, number for the number of students on the left hand side right here. Okay, and then we have the title. Bar graph, we change it to line chart or line graph. Line chart or line graph of UMT students by intake year. And then we have the legend for the genders. We give them the title, and then we can run it, and we can see. Done. Just as simple as that. So what we can say is that if we had the knowledge on how to plot bar charts, we technically have the knowledge on how to plot out a line chart already. It's pretty straightforward. It's not really that complicated. You do have to take note that you need to know how to put the title. You need to know how to give them the X label, the Y label, and the legend, so that you can give them all the information that the client needs when they are trying to interpret the graph itself. So for the line graph, it's nothing much. It's not that complicated. And as long as you follow the steps, like I mentioned here, using plot, give them the values, the X value, the Y value, the width, and so on with the necessary attributes, you can straight away get these graph like in no time, like really short time, just 5 minutes to 10 minutes. You can already make some impressive visualizations for you to present or to do the storytelling. Okay. So this is it for the line graph, bar chart, and the pie chart. So let us recall a bit. Okay, let's recall a bit. So for pie chart, we had this particular section. We had this whole pie chart by performing this kind of coding. plt.py, and then we just include the values of the data. We don't need to include the labels. We just include the data. If we have something that we want to do settings on, we just put in the common attributes right here. And then we just give them the labels, the starting angle, if you want them to be separated from the center, if you want them to give them shadow or shades of gray under here, if you want to change the color, and then just show them. That is it. For bar graph, similarly, instead of pi, we use bar, and then we put in the X values, we put in the Y values, and then we put in all the necessary attributes that we want to use. Okay. Now for this one, for this last one, the bar position, the way it works is that we put in the X values first, and then we put in the width, the position, the transition, how the value on how much we want to move this bar chart to the left or to the right. So if you want them to move more, like here, for example, if we want to move this one more for this section, instead of minus 0.15, we can put minus 0.3. And then we can put plus 0.3. And you can see it'll be a lot more far away from the center itself. Okay, this is one thing to take note. We want to make them group properly, so we don't want to see this kind of huge gap between like similar bars. Okay, so the best way is to keep on testing, make sure you have some idea on how you can visualize it, and you can make a simple yet informative bar chart. Okay, now the attributes that we can use are all these, but not limited. Okay, not limited to all of these. There are other options, but these are the common ones. Okay, these are the common ones, and we can use them to create typical bar charts group bar charts, or we can use them to create stack bar charts. Okay, we can use them to create stack bar charts. And lastly, it will be the line graph. It's similar to bar graph with different attributes and different elements. We use plt.plot instead, and then we have the same thing. We have x values, y values, and other common attributes such as line style, line width, and color. Okay, for the color, it's the same thing. We can put in any color that we want as long as the system can read it. And then for the line style, we have the dashed or the dotted version. And then we can set the line width to be thicker or thinner. Okay, like if we want change it to 2.0, it will be a lot thicker, right? This is how we perform line charts, okay? Now, this is the end of the hands-on session, okay? Now I'll go into the visualization dashboard, okay? Everyone so far so good? If everyone's okay, I'll straight away continue to the visualization dashboard. All right. Okay, so I'll continue on the visualization dashboard. So if we have already done all these visualizations, like these pie charts, bar graph, and line graph, what are we supposed to do with them? So what we want to do is that we want to create this dashboard so that we can present this information using the charts that we made just now. And then we use them to provide context, information, and insights, okay? So how can I make a good dashboard? How can we make a good dashboard so that we can present our information? So the way we can make a good dashboard is to consider these three main categories: the presentation part, the data or the visuals part, and the clarity section, okay? So for these three, let's think it like this. Who are your audience? Before you present anything, before you show any information, you must know who are your audience, who are the ones listening to your presentation, who are the ones that will be making decisions. You want to give them the information in the way they can understand. Okay, what is their culture? Do they emphasize on numbers more? Do they emphasize on percentages more? What's the common way of them communicating or understanding information? And next one, what do they want to grow? What do they want to know? If I give you a lot of information that you have no interest on, then what's the point of making this visualization? No point. We want to make sure that we know what does the customer want. Only then we know what to visualize and what to present. Okay, and what are the goals? You need to know what is the main purpose for you to present this storytelling. If they want to make decision on whether they want to buy this thing, you should give them the information with the mindset of persuading them to not buy or buy this product. That's your goal. And the next one is, how much time do they have? Do they have 10 minutes of time to listen to your presentation, or do they only have 5 minutes, 30 minutes, or 1 hour? You need to make the dashboard based on the time they have. If they want to spend a long time to listen to a presentation, make sure you have enough information for them to know this much information based on the time they have. So if they have 30 minutes, make sure you have 30 minutes of information for them to understand. Okay. The next one, what should they know? If they have this one goal, how should you let them know what they want? How should you show them the thing that will help in making decisions? You need to know what to show. Okay. And how can we make them understand better? If they understand it through figures, how can you make the figures easier to understand? How can you make the information easier to digest? It's like trying to present something it's like trying to present something that they can relate to. You need to make sure that they know this, they are in this culture, they understand what you're trying to tell, only then they can understand better. Next one, is it too overwhelming? If there are too many visuals, if there are too many graphs, 10 to 20 graphs, they might feel too imitated about it, because in our brain, we can only accept this much of information within one time. If you suddenly show them 30 to 50 graphs in there, I bet most of them don't know what to focus or how to focus already, right? Next one, is it simple and direct enough? We want to make sure that the data is straightforward. We want to show that, oh, this is the key information, nothing else. Anything that is not important, we shouldn't let them know. We should only show them the important ones, and this important information must be easy to understand, okay? Next one, are the numbers easy to read? Sometimes we usually get to a point where we just put in all numbers into it. Like, let's say if we get 32.09991%, we don't actually put 32.09991% in the dashboard straight away. We don't, because not all of them can comprehend the numbers that easily. And you also need to know whether the numbers are important. Is 0.09991% that important? If it is, based on the culture, yes, you need to put it in. If it's not, then you shouldn't put it in. Just show them 32% is enough. Okay. Now, the last category, clarity. Is this information written wrongly? You need to double check on your information before you do the storytelling. Because if you get the information wrong, you let them to make wrong decisions. And if you are trying to do the storytelling in an organization, you will make them lose a lot of profit. So it is important that you make sure the information is correct. And next one, you need to make sure the explanation is direct and clear. It's just similar to data and visuals on how you can make them understand better. If you can make them understand better with simple and direct information, the explanation itself is usually pretty direct and clear already. So you need to make sure that you are telling the right story with the right amount of length, the right number of words without making it too lengthy. Okay, next one is the information making sense of it. You cannot tell them this one suggests that they shouldn't buy, and then the other information suggests that they should buy. It doesn't really make sense logically. You are not giving them the solution on how you can make decisions. So you need to make sure all your informations are logical. Now, last one, last two ones. Is everything in similar format? You need to make sure that everything is in similar color palette. If everything uses red, use red for all of them. If they are using percentage, make sure all of them are written in percentages. You don't put in percentage and suddenly figures and suddenly words in there. It is not consistent. And lastly, are the labels clear and direct? You need to make sure that they know what do these parts of the label represent. You cannot put in a long name that they cannot understand, and they ended up not understanding what is the graph about. So this is a very important feature, okay? So now, let us think of how we can visualize and explain these three graphs and present it in a storytelling way. This is what we need to do after visualizing data. So let me show you an example on how we can visualize this and explain it to a person, to a customer or to a client, okay? Now, let's start. Good evening, everyone. Today, I'll be showcasing a few graphs about how the students' performance recently based on three different metrics: gender, attendance, and CGPA indicator. So let's look at gender at first. For the gender, you can see that there are more female students compared to the male students of up to 33%. Looking at the attendance rate, we have already classified them into IT01 and BI02, these two courses. In these two courses, one of the course, IT01, has around 30% of them not fulfilling the minimum attendance rate of 80%. While for the other course, BI02, all of them completely fulfill the attendance rate. Okay. Now, when we look at the CGPA indicator, we've looked at them in two different approaches. The first one will be CGPA based on the attendance rate. The second one will be average CGPA. So when we look at the average CGPA, we can see that IT01 students have generally lower CGPA compared to the BI02 students. But surprisingly, the CGPA to attendance rate for IT01 students are actually higher compared to the BI02 students. The main key feature in here is that IT01 students, they have higher CTA rate of 2% despite falling off by 175% in the average CGPA difference. This means that for our priority, we should be focusing in ensuring that all students fulfill their minimum attendance rate of 80%. Also, we should review the academic approach that we implemented in our campus, such that the students who attended more for the classes will also perform better in terms of CGPA. That is all for the storytelling. Thank you. This is how we perform the data visualization, and after that, perform the storytelling on what these visuals about, what these visuals are about. This is how we perform it. Okay. Now we are getting close to the end of our event. Let us make a really short recap of what we have learned today. Okay. So to recap, data visualization is a process of presenting data using visual elements. Okay. The main purpose for us to perform data visualization is to understand the patterns and relationships. And afterwards, we need to use this to communicate information or to perform storytelling with the audience or the clients. And such that we can use it to make quick data-driven decisions. We make decisions with actual information that we can understand. The basic techniques or tools that we have used today was pie chart, the first one. Second one will be the bar charts, and the other one will be the line graph. And for the tools, we use Google Colab for today by Python. These are the tools that we have used today, and we have other additional options that we didn't use, which I mentioned before this. So for dashboard design, we need to focus on 3 aspects. First one is the presentation. Second one is the data of visuals. Third one is the clarity. For the presentation, we need to know the audience and its culture. And then we need to know what's the main purpose of this presentation. For the data and visuals, we need to provide context and relevant information, pick the visual elements carefully, and we need to make sure the visuals are all simple and the numbers are all rounded off, unless it does not fulfill the goal. Lastly, we need to make sure all the presented visual elements are proofread, no grammar mistakes, no all spelling errors, and we need to make sure all the information are correct. And we need to make sure that the format and the labeling is in consistent format as well. Okay, that is all for our recap. All right, now we get into the Q&A session. Do you guys have any questions? You guys can open the mic if you guys want to ask any questions. Will I host more talks in the future? Yeah, sure. I'll host more talks in the future. It depends on our schedule and our roadmap. You can stay tuned on afterwards. I'll show you the link to follow our GDSE group. Anything else? Any other questions? What about certifications? What kind of certifications? All right, let me stop this recording first.